little bit more detail about those 3 tools, show you what they are, how they work, and how they do what they do. Again, I'm gonna keep driving home to you. Number 1, improving irrigation application timing. You know, when I started Mississippi State, they're like, you know, we don't really know when we start irrigating. We're not real sure when we stop. We definitely don't know what to do. We're in the middle of a 6 or 7 irrigation set spin. We get a 2-inch rainfall or an inch rainfall. What do we do? So we'll talk about how to use sensors and plant physiology to take care of all those questions. And then, you know, 80% of the Delta's furrow irrigated, and they charged me with making you better furrow irrigators. I only got a couple of tools. Number 1, PHAUCET or Delta Plastics Pipe Planter. That tool allows me to get the irrigation set right where I can get it on and off it, and then what your specialist is going to tell you to do, ideally 24 hours. Get all the water to the furrow at about the same time so we can get on and off as quickly as possible. That's what PHAUCET or Delta Plastic Pipe Planter does for you. Gets those set size right, gets the time right, and get the water to the end of the field correctly. And the only other tool we got really is these surge valves. That's it. So we'll talk about those in a little bit more detail. So this is the kind of setup that we use for the soil moisture sensors this past season. This is a little Hansen data logger. You know, the field's out here, so we would wire this in, get the data to the edge of the field. It was 1 button that you'd push, so it's almost idiot-proof to get the data, interpret it. And then we would put sensors in at 6, 12, 24, and 36 inches on top of the bed as close to the, you know, the crop as possible. Because what you're really trying to do then in a situation like this is that these sensors are potentially reading on, you know, 4 40-acre fields. You know, we got to strip this wide with sensors in it, and we're trying to make decisions over something that stretches about a foot over 180 acres. I mean, it sounds like a stretch, but again, just think back to the data we showed you. It looks like it works fairly well. Some of the advantages of using these soil moisture sensors, you know, when they ask me, you know, when do we start, when do we stop, what do we do in rainfall and event, the real answer, nobody's ever really told you that, is that what we're trying to do is that for 50 years, they've pretty much known that if you deplete more than 50% of that plant available water in the rooting zone, then you've set yourself up to have a yield loss. But if you've got more than 50% plant available water, the plants ought to have adequate moisture to do what they need to do. But you can't really detect that all the time if you're pulling the trigger every 7 days or 10 days or doing what your neighbor's doing. These soil moisture sensors allow you to measure when you're getting close to 50% plant available water and pull the trigger. So that's an advantage for it. So it gives us a hard line for when to start, when to stop, and when to do with the rainfall in between. That's one we keep telling you as a row crop team, is that we really don't see a way, you know, with impending regulation, declining offer levels, to make you a better irrigator unless we have a tool like this in the field. Some agronomic type things that we can read from these sensors stuck in these profiles at different depths is that, you know, number 1, you can see what a 1/4 inch rainfall does or does not do to you for a given soil type. You can see when what we, you know, affectionately refer to as sealing issues, which happens frequently on these Dundee type silt loams, traditional cotton soils. And what I mean by that is a lot of you are irrigating, you don't have a flow meter on, you don't have it set up on faucet, you're running water till it hits the tail ditch, and on some of these sealing soil types, what you're effectively doing, after we've dealt with a lot of them up and down the Delta, is putting about 0.85 acre inches out every 7 or 10 days, which you can put more water out with a pivot and probably cut a better yield. Just going to kind of go through this real quick. You know, again, these sensors are trying to give us an idea of what 50% plant available water is and pulling the trigger based on that. So 50% of the soil in a volume basis is going to be solid material, 50% is going to be pore space, and a fraction of that's going to be taken up with water. So that's field capacity. You know, if y'all been like Mississippi State or something like that, and you talk about soils, this is, you know, somewhere usually around what we would call a 3rd bar. That's the soil's drained out, it's charged, it's ready to give the plant what it needs. The opposite end of that is the permanent wilting point, which means usually in these same units, that's around 1,500 kilopascals, which means the plant's not coming back, it's dead. So the difference between this field capacity and permanent wilting point is the plant available water. Again, just trying to drive home how we did this on your farms. We put them at 6, 12, 24, and 36 inches. There's some NRCS models that would allow us to take sand, silt, clay, organic fraction, bulk density into account to kind of help set a threshold what we think that plant available water line would be on that sensor. We drove by and checked them about twice a week. We based the irrigations on what was going on in the rooting zone. Again, we had them down to 36 inches. You know, let's say corn's at B12, we may only have root activity at 12 inches. Which means that at 24 and 36, those sensors are saying they're saturated, and I'm saying there's no plant roots down there, so I would only look at what's going on in those 12 inches and schedule irrigation vents based on that. Let's say we got closer to tasseling and actually had those sensors were reading, now look, I got water going away down to 36 inches, then I can start scheduling irrigations on that whole 36 inches. Every foot I go down deeper, I got about an inch, inch and a half more water. I don't have to apply with irrigation. I can take advantage of that plant using it in the profile. Where do we place them? All right, so if you're in a pivot type, this is just a general background common sense approach that we use this season, is that I would ask, we came on your farm, I was like, look, you got a yield map for this field. Most of the time we did. So I'd look at the yield map underneath the pivot, put in a representative yield potential of the field in the outer span of the pivot, and then use a lot of common sense after that. You know, we would put them in after the crop's established. So you want a representative stand, representative health, all those kind of things away from traffic mills. Put the sensors in at 6, 12, 24, and 36 inches. And then same kind of approach when we were doing furrow irrigation events is that we would look at a yield map, look for representative yield potential. If it was a crack and clay or a mixed soil type, we would put them towards the middle of the field because we know we can oversaturate the top part of the field and you can maybe get not enough water on the back side of the field. So we'd put it right in the middle of the crack and clays. If it was those Dundee silt loam soils, the traditional cotton soils, we saw in too many situations you weren't getting enough penetration of water in the irrigation event. To drive that home to the producer, to drive that home to you, we would move the sensors back to the back third of the field because that's where it's going to be drier, trying to drive home to you that this field is drier than I perceive it to be. Does that make sense? So that's using sensor tech. That's timing. That's when do we pull the trigger, when do we stop irrigating, what we do in between. Sensors. That's our solution to you. We need sensors in the field. Now this next section is like, okay, I've got poly pipe out there. People want me to be a better furrow irrigator. How do I maximize the delivery, the efficient delivery of water using poly pipe? So to do that, we got to first understand what irrigation application efficiency is. We're trying to stack water in that rooting zone of that crop. The plant's using it up, I'm trying to get it back in there, and you're trying to get it back in there in the irrigation event. If it goes out of that rooting zone or never makes it into the rooting zone, that takes away from my efficiency.